Okay, so I am moving on with our learning targets. I'm trying to get us to where we can solve two-step inequalities, but there's this very important rule with inequalities when you have to multiply or divide with a negative number. So you're going to be exposed to that today. We're going to first multiply and divide with regular numbers. So when you solve with multiplication and division, again, you just do the opposite. So some students struggle knowing when do I divide, when do I multiply. If the number is on the denominator is when you multiply. If it's sticking right next to it as a numerator, that's when you would divide. So I'm going to divide each side by 3, and I get x is less than negative 3. Easier than yesterday's. However, it gets tricky because there's something special that happens when the number in front of x is negative. So I would have a open circle at negative 3, and I would go to the left. Okay, next one, x over 4 is greater than or equal to negative 1. This really means x divided by 4 is greater than or equal to negative 1. So in order to get rid of dividing, I will multiply to both sides. And I get x is greater than or equal to negative 4. Colored in circle at negative 4, and I go to the right. And then, of course, if you have the variable on the opposite side, remember you have to flip the direction of the arrow here. So I'm going to divide both sides by 2. And I get 5 is less than x. 2 ways you can do this. So you can think logically. If 5 is less than x, then that tells me x has to be greater than 5. Or think logically. Or not logically, but that little trick. Like the arrow is supposed to go this way. It's on the opposite side, so it will go the other way. You will have fractions today. Fractions, what I would do, you can multiply through by the reciprocal. So times both sides by 4 over 3. Or I personally like to just get rid of that denominator. So here I would times both sides by 4. Remember, you have to maintain that equality. That cancels my 4 out. And I get 8 is greater than or equal to 3x. That 3 is still there. It's going to be a fraction answer. It's okay. Trust your algebra. Divide by 3. And 8/3 is greater than or equal to x. Now how do you graph 8/3? So I'm just going to make a rough estimate. So I'm going to kind of convert this into a rough decimal.
It's
3 goes into 8 2 whole times. 2 remains. 3 is a denominator, which I know is 2.6 repeating. So it's kind of close to 3. So I'd have a colored in circle by the 3. Now it's flipped. So instead of going to the right, I am going to the left. Okay, now here, this next page is the important, super duper duper important page. So make sure that you are not distracted by anything and you are ready to listen. Okay, so there's 2 different properties, the multiplication property of equality and the division property of equality. It says that what you do to one thing, you can do to the other side, and it maintains its trueness, its meaning. So here, do you agree, this is true statements, do you agree that 3 is bigger than 1?
Yeah.
Do you agree that negative 2 is smaller than 4?
Yeah.
Okay, then the multiplication property of equality says that I could times both sides by 4, and it should stay true. What's 4 times 3?
12.
12. Is 12 bigger than, what's 1 times 4? 4. Yes, that is true. So maintained its equality there. Let's times both sides by 7. Okay. Oh, let's divide, because I said multiplication and division. So let's divide both sides by 2. That seems, since they're both even. So if I divide by 2, according to that property, it should remain a true statement. Negative 2 divided by 2 is negative 1. Is that smaller than 2? Yes. Now notice what I did. Positive, positive. So it's true when I did something with positive numbers. So it was true with positive numbers. Meaning I can multiply an inequality, I can divide an inequality by a positive number, and it maintains its truth. Now it doesn't always maintain its truth. And I'm assuming now you can figure out that if I was talking about positive numbers, something's going to happen with negative numbers. So I'm starting with a true statement. Is 9 bigger than 3? Yes or no?
Yeah.
Okay. Now watch what I'm going to do. I'm going to times both sides by a random negative number, negative 2. What's negative 2 times 9? Negative 18. 3 times negative 2 is negative 6. Is negative 18 bigger than negative 6? No. The more negatives you have, the smaller it is. This is false. Something happened with the inequality when I times through by a negative number. So in order to maintain the truth of the inequality, you have to flip this. So it would really be negative 18 is smaller than negative 6. Because what happened is I went through by a negative number, and that's okay because algebra does that all the time. But then it made a false inequality statement, so I had to turn it back into a true statement, so I flipped my inequality. I'm going to show you that it also works with negative numbers. I'm going to divide both sides by negative 2. Negative 2 divided by negative 2 is what? Positive 1 is less than. 4 divided by negative 2 is negative 2. Is this a true statement? No. So I have to turn it back into a true statement, and I have to change that inequality. I have to flip it. So it has to be 1 is greater than negative 2. Okay, so with false statements, we noticed that when we multiplied and divided by a negative number, we ended up having to flip that inequality to maintain the truth of the inequality. So this only happens with negative numbers. So if you're dealing with positive numbers, it's true. When you deal with negative numbers, it turns false, and we end up having to flip in order to make sure that it stays true. It is one of the hardest concepts for 8th graders to master because it's pretty abstract. That's why I wanted to show you that multiplying and dividing by negative turns a whole inequality into a false situation. We call it MD&F. So you're going to hear me say that a lot. I'm going to be like, oh, you forgot to MD&F it. You got to MD&F that. You got to MD&F means if you multiply and divide by a negative, you need to flip the inequality. So when you hear me say MD&F, MD&F means multiply and divide by a negative, you have to flip. And you always do it last. You flip last. Here's when you know that you have to MD&F an inequality. If the negative is to the left, like negative 3x is bigger than 9, I would have to divide by a negative 3, and that would give me a false statement. So you would have to flip to maintain its truth. And then if the negative is under, like this, x over negative 4 is less than or equal to 3. Because I would multiply through by a negative. If you remember, when I multiplied through by a negative, I got a false statement. So in order to turn it into a true statement, you have to flip the inequality. So that's, and today you're going to have to decipher. You're going to be given a bunch of different types of problems, and you're going to have to be able to know, am I going to flip it or am I not going to flip it? And you flip if the last thing you do is moving a negative number, you flip it. If it's connected, only if you're multiplying or dividing. So I want you to be able to isolate. Remember, we're looking for a negative to the left of a variable or under. So looking at this, whoop, oh, they're all grouped together. Hold on. Okay, so looking at this first inequality, 4x is less than or equal to 6. Would I be moving a negative number? Is there a negative to the left? No. I would just move up my 4. 4 is positive. So I would not flip. I would not flip it. What about this one? Would I flip this one? Negative 7x plus 2 is bigger than 3. So I would subtract 2, and then I would divide by a negative. When you divide by a negative, you have to flip. It turns into a false statement. Negative 65x is bigger than negative 2. Flip or don't flip? What do you think? Flip, because you're going to divide by a negative. This would be a flipper. 19 minus x is bigger than 4. You actually flip this one because it's a negative 1x. So you would end up moving a negative 1 at the end. This is a flipper. Maybe show that you know that with the plus and negative 1. Flip or don't flip? Flip, because it turns to negative 1. So I would divide by a negative. When you divide by a negative, it made a false statement, so you have to flip it to turn it back to a true statement. Flip or don't flip?
Don't flip.
Flip, negative
Negative 1.
1.
You have to divide by negative 1 in there. Yeah, that's a flipper. No flip, because it turns to plus plus. Because this turns to 3 plus x is smaller than 11. You do not flip that one. What about this? This turns into 3x. 2 negatives turn into a positive. 3x is greater than negative 2. I would divide by a positive 3. That is not a flipper. So, again, if you ever wonder if you're going to flip it or not, it's if the last thing you do is move a negative number by multiplying or dividing, you must flip it. Okay. I want to do fractions, but I kind of want to give you examples of when you flip or not. So we'll just do the examples while we're working through the fractions. We'll do the flipping. Okay, so there's 2 ways you can deal with fractions. We've talked about it in Unit 2. You can make sure there's fractions on both sides. That means like if you have 3 is bigger than negative 2/3 x, you would turn it as 3 over 1. It's putting a 1 on the denominator if you have to. Or you can get rid of the denominator right away. So this first one, I have 6x is bigger than 1/5. I would divide by 6 and I feel stuck. Because I have a fraction there and I'm going to be like, how the heck do I do that? That is one that I would put a 1 on the denominator. Because then you can deal with it much better. So I would times through by 1 over 6 by 1 over 6. And it's positive, so it maintains its truth. So x is bigger than 1 over 30. And luckily today you don't have to actually graph that.